We are going to talk about now a very often confused aspect of Ruby, and which is the class hierarchy. Now, in Ruby, every class that you define has basic object as its superclass in one way or another. Basic object class. Now, what is a superclass? Superclass is basically the class from which you have derived, right? If you write a class called car and you derive it from, let's say a class called vehicle, then vehicle is your superclass and car is your subclass. In Ruby, every class that you define has basic objects on its top actually, the top of the food chain. And one distinction to remember is if you are programming in 1.8 didn't have basic object, there it was object class. So top of every class has object as its superclass. And in 1.9 the top level class is basic object. The reason these two are introduced is very it's for theoretical. This thing historical reason is very interesting. Let's say you're defining, you're writing a DSL and you create a class. The moment you create a class, since your superclass is object, you say class car, automatically your class is a subclass of object. You get all the methods defined inside object class, and it has quite a lot of methods actually, like 20-30 methods at least more. And you're writing a DSL, and some of the methods that object defines collides with the methods that you are trying to define. You don't want that. So for that reason, people hacked around it a bit, but in 1.9 made it much simpler. They created a class called basic object, which is a superclass of all the classes, mother of all, and it doesn't have any methods literally. One or two methods are there, but it doesn't have any methods literally, and that's a blank state. So if you're writing a DSL or something like that, your class should inherit basic object rather than object. Okay. So I'll just go slowly into this slide and try to explain the object hierarchy. There's a class called car. Okay. You have defined a class called car. Initialize in an instance variable called Ferrari, very nice. So when you define the class car, you have a, let's call it thing for now. I won't call it object class. I'll just refer it as a thing. Okay. So there's a thing called car. Right? Now, this thing car, it's a class, and there is a class called object, and object is the superclass of your class called car. Make sense? So, car basically subclasses this class called object. Even though you are not writing that subclass declaration here. How many of you are familiar with the subclass, the way you subclass in Ruby? You just give less than symbol and then write something, right? Even though you are not doing that, it is implicit in the code, okay? Now, there is a class called basic object, and that guy is a superclass of this class called object. Okay, makes sense. Now, when you create I'm creating an instance of this car class and calling it Ferrari, and assigning to a variable called Ferrari, and that is an instance of that class called car. Now, since this class called car is a subclass of object as well as basic object, all the instance methods defined inside car, object class, basic object class, all are accessible from this object called Ferrari.
Right. That makes sense to everybody, right? You're getting the gist of it.
Yeah. Now, here's where it gets tricky. In Ruby there's a class called class actually. Okay. And as we talked before, every class is an object. Okay? So the class that you define car is nothing but an instance of this class called class.
Okay, so new Ruby is getting confused at this point. Please stick your hands up and ask, because especially if you're coming from a background in C# Java, this can throw you.
Yeah, please. So this really needs to we need to hammer down this that this car that the moment you said class car, this line that is there, this class car line, it is like saying, it is same as saying car equal to class.new. I don't have maybe I can just switch to. So let's say I have a class called I defined a class called car now. Okay. So this is same as car equal to class.new. Probably a bit of warning here.
No, you don't even have to give car. That's the inheritor and the target. You can leave it in.
Already initialized, but yeah. So So the point is that that class car and car equal to class.new are same basically.
So this is actually illustrates a thing I was talking about earlier, so I'll digress very slightly. There is actually one subtle difference between the first line and second line, though the outcome is the same. Either way, a class called car is created. Anybody want to guess what it is? There is a subtle difference between the first thing and the second thing that Hemant did. Actually, the outcome is the same. Either way, you get a class called car. But there is a subtle difference, and I mentioned this earlier when we were talking about it. I said not everything is an object sometimes. The first one is an interpreter hack effectively. Right? If you override, if you open the, so you can open everything, right, in Ruby, no doubt about it. If you open class, okay, and override initialize to throw an exception, the second line will pop. Right? You understand what I did? I reopened the class and said the constructor throws an exception. Logically, you would expect both to fail. Actually, only the second one is. Because the first one is actually bypassing everything to go straight to the interpreter to speed up the creation of classes. So if you see, you're getting a runtime error. Right? So what Hemant did in that line number 19 in the middle is he's opened up class, overridden the construct. And you can do stuff like this, right? Now if you look at this, you'll understand why so many Ruby code bases are such a mess. Right? It's easy to completely destroy your interpreter itself, forget about anything else. So def initialize, throw an exception, and close it. And you can see when he does foo equal to class.new, it blows up. But could you just quickly do class something else? Class bar? Was right? So in any case where you have literals, what is it called as a term for it? Literals, double quotes and brackets and all that. String literal, right? Yeah. So the literal form of, this is called the literal form, right? Where you have a shortcut, a syntactic shortcut. So square brackets for arrays, curly braces for hash, double quotes, single quotes for strings, and small class for class. All of these things actually hack straight into the interpreter. Yeah. So if you override new in string, override new in array to do something like this, array.new will bomb, square bracket still works.
Yeah, so shorthand for initializing basically the objects. Yeah. That still works, but if you go via the conventional route, they'll bomb that. So we were at your class called class is your car class is an object like any other object, and it is an instance of this class called class. Okay. Now, to make things more muddled, there is a class called module. Okay.
Class called module.
Class called module. Okay. The class called module, and that class is a super class of this class called class. Okay. Right?
The class called module, which is the superclass of the class called class.
Right?
If nobody is confused at this point, I'm very impressed.
So let's if you have used things like include, you write include, right? We in the previous slide, in one of the slides, when we were doing. So we have include here, right? This include is nothing but a method. From where it came? From where that method came? And that method came nothing but okay. So that include method that we use when we declaring class, from where it came? It came from this module, this class called module actually. So we talked about that when you created an object called Ferrari, you had access to all the instance methods defined in class called car, in class called object, in class called basic object. All the instance method you had access in that object. Similarly, inside this car, which is inside this object called car, which is the instance of this class called class, you have access to all the instance methods defined inside class called class, all the instance methods defined inside class module. So when you say include method is defined here in this class called module actually. Okay? And that basically this class, if you are going to shoot yourself and do a lot of meta programming, that is the place to start. This class called module actually. You go and read that what all is defined, and that is the that is the mothership of meta programming. This class called module, very important. Clear? So all the methods that you use at class scope in the car directly, all of them come from this class called module. The class itself has very few methods actually. I don't remember what they are, but they have very few methods. Most of the methods come from this class called module actually. Clear? Now to make it more confusing, there is a class called object as you know it, and that is a super class of this class module actually. And there is a class called basic object, and that is a super class of.
So just to be clear, like these are the same thing. Like another way to render this would be the graph converges there. They're the same thing. It's not that there's two unlabeled different objects and basic objects. It's the same thing. And it just goes to illustrate again the fact that modules classes are objects.
Module classes are objects, and all the classes have a basic object at its super class.
And the interesting thing in all of this is a thing that you struggle with, or at least I struggled with for a while until I realized, which is that it's a chicken and egg problem, right? In a class-based object, you don't have this in JavaScript. JavaScript doesn't have classes, right? Right? Nobody's seen classes unless you use certain libraries. There are no classes. So you create an object in JavaScript. Where does it come from? Right? Ever thought about that? I say new object. It just shows up. There's no class. So this is called ex nihilo creation from nothing. And in a class-based object-oriented language, the chicken and egg problem is which came first, the object or the class? Right? So if you look at basic object, which class does that basic object belong to?
Yeah.
So eventually what you have to accept is something is created ex nihilo. In the Ruby graph, it is right there on top, basic object. That object, so basic object itself is an object, it has to be. Right? Everything in Ruby is an object. That object just exists. It is there already, courtesy of the interpreter. Ex nihilo creation.
Okay. So to make matters more interesting, this class object, this is a class, right? So that itself is an instance of this class called class actually. So this object thing, I won't even call it a class or object at this point. But this object thing is basically a super class of class as well as an instance of this class called class. Okay, this guy is not just a super class of this class. It is also an instance of this class called class. Similarly, this basic object is super class as well as an instance of this. And this class called module is a super class as well as an instance of the class called class.
So basically, except that this graph is set up for you in the interpreter. It exists. Beyond a certain point, like I said, it's a chicken and egg. Like, okay, they picked this way to set it up. This is how it's set up.
And is it planned to this level? When we are writing programs day to day, how often do we come to this graph issue? How often do you have to think about
Yeah, so one thing, when you are especially doing like bit of meta programming, okay, at that time you got to understand this, that this is how my object graph is set up, okay. You need to understand that from where this, if you're writing an included hook, for example, that a lot of people do, you've got to understand from where that included hook is coming and what is my object. So unless you're doing a lot of meta programming, you don't need to, you need to be very careful about this. From the right part you need to always know it apart. Yeah. But the left part where like module and the way interaction is, unless you are doing a lot of meta programming, you should know this. You should know. But if you are doing meta programming or you're writing gems and you want to structure your code properly, this understanding this object model helps.
So the other case which I've realized is in Ruby, if you're developing in Rails, you will be using a lot of gems, right? A lot of gems uses some of these concepts. So sometimes even if you are not doing meta programming, but for you to just understand, the source code of, the gems and, for you to debug certain things, some of these concepts becomes very, very handy.
Yeah.
The most common confusion will happen when you're trying to figure out the flow of some code, and especially the interaction between object, module, and class, without going to basic object and without worrying about the inheritance starts mattering because you're trying to figure out where a method came from. How is this method here? Is it getting overridden somewhere? right? And then there are other questions which you need to actually experiment and figure out, wherein if I include two modules and each of them has the same method, which is available to me? If the class itself has the same method and all three are now overriding, which is the one that becomes available? All of these things you will run into, but you know, it's a matter of time. Sooner or later you will run into them, and that's when that part becomes important.
That part becomes like Bhavin already said, even if you are trying to run away as far as from it possible, you will have gems. Ruby gems and Rails gems in particular have this bad problem, leaky abstractions. You will have to go and read the code all the time. There is no other go. And at that time, if you don't understand this, understanding that gem code itself is hard. Okay?
1.9, at least to make the method overriding problem simpler, in 1.9 it's called what method. There's a way to figure out which module the method is from. I forget the name of that. There's a call you can make on the method object, which will tell you which module of class the method is from.
Generally, I use that method source or price. Source location, yeah.
Source location. So, just a helpful thing which, if I had known, there were hacks for it on 1.8 as well, but would have made my life easier. If you're getting confused as to where a method is coming from, believe me, it will happen, give it enough time. There is that particular thing, source location.
But basically a better approach is just install pry, and
Or
pry has a
pry.
method called show method, pass it the string, and it will show you the full thing, like okay, where the heck this is defined.
Or just use a debugger, step on it and see where it's going.
No, but if the method is meta-programmatically defined, then it might be confusing from where it was defined.
And somebody hasn't put their underscore line,
Yeah, underscore.
they haven't done their basic due diligence with class eval, then you're completely
Pry is actually very helpful. Like if people start, Pry is very helpful actually.
Yeah.
People start using, it's very good to use.
Yeah, absolutely.
Just want to clarify this Ruby relationship where there is a begin but which we can't go beyond. This is a cycle dependency, right?
Yeah,
So
there is a
you come back again.
Yeah.
I just want to make sure that for newbies it doesn't matter that much because it might be giving, it's still complicated at this point.
It is
So I think the point of the lesson is it is complicated.
Yes.
And you will need it eventually.
So,
Yeah.
so that's the reason I'm going next. We are going to give you some resources that you please go ahead and read if you want to be really comfortable with this. This 2 minutes of explaining this basic object, which takes years to understand, totally really engross it. That is hard. So you just go read it. That's the best thing to do.